Hello, my name is Mauricio Sousa, and I'm a product marketing manager for Intel Corporation. I work specifically in the logistics and asset management segment within our Internet of Things group. So thanks for joining today, and the presentation that I will share with you, it's with regards to our Intel Connected Logistics platform. So before I begin, let me give you a little background about myself. So I've been in this role for about a year. I've been at Intel for a total of 5.5 years. I spent my previous 4.5 years in Intel supply chain organization. I was doing all sorts of procurement while I was in that role. I was a commodity manager working on global sourcing for some of our gases and chemicals. And now that I'm in this role, I work on developing and deploying products, IoT products for the logistics and supply chain industry. So the reason why I wanted to go through that is because just to give you, a little preview of Intel supply chain. And one, the immediate word that comes to mind is that it's very large, right? So if you see the information here on the right, we're shipping over 1 billion units to over 68 different countries. Our supply chain organization manages about 10,000 suppliers in about 100 different countries. We have over 1 million invoices. We're shipping to 3,300 locations. We manage 24 global warehouses. So there's a lot of folks. I believe our entire supply chain organization is just over 2,000 people. And most recently, we were recognized by Gartner, a supply chain organization, as the number 6 most important in supply chain globally, right? Just behind Unilever, McDonald's, Cisco, H&M, and Inditex. Now, the reason why I bring this up is because, a few years back, our supply chain team, started looking at what were their major challenges, what were the major pain points in the industry and within our own organization, right? And how can we use technology to address them? And one of the items that came up and that really stood out and resonated throughout the organization was this concept of supply chain visibility, right? So I think if you're familiar with the logistics industry, this concept should not be new. Right, so knowing where my product is from manufacturing all the way to delivery to the end user, and this can be location and this can be condition. So, the team looked at this and as it applied to capital equipment, right, constantly trying to understand where the capital equipment is, either coming from Europe, coming from Asia, or from the US, shipping to our global factories, right? So that we can plan accordingly. And whether it's for preventive maintenance, whether it's for, a new product development, et cetera. So they developed a prototype solution, a prototype technology that addressed some of this challenge, and they reached out to the business unit, the Internet of Things group, and that's how our organization came about, the logistics and asset management segment division. We said, we think that there is a lot of value here, not only for Intel but for the industry as a whole, right? And as I transition here, why did the business unit decide to look at this so closely, and why were we so interested in closely following this market and seeing if there was an opportunity here? It's because the global logistics market is very large, right? So you see this data point here for 2015. The global logistics spending is just over $8 trillion. That's about 15% of the global GDP. Right. And when I say logistics spending, there are subcategories. This is everything from warehousing, transportation, value-added services, trade facilitation. So that's kind of like the customs control and getting all the paperwork requirements as you move material from one place to the other. But one of the interesting things that that we see is that this trend in logistics spending is going up, right? So by 2020, the spends in logistics are supposed to increase by almost 20% to just over $10.5 trillion. But if you notice here on the graph, right, we are, again, I'm part of the Internet of Things group. We're looking at how can we use technology to better help, the third-party logistics companies, end users that are moving valuable product worldwide. It's this value-added services, right? And it's expected more to double from 2015 to 2020, right? So $0.4 trillion to just over $1 trillion. And that figure is significant, right? And, like I mentioned in the previous slide, when we talk about supply chain visibility, the technologies and products that are out in the market today that to address that challenge, right, would fall under the category of, these value-added services, this, whether it's a device that's being placed on a shipment, or whether it's a control tower, these fall under this category. Now, before I move on to the next slide, so another interesting, fact about the logistics market is the amount of the volume, just the sheer volume of shipments that went around the globe in 2016, right? 76 billion shipments, right? And you can start, tying things together, right? So we talk about supply chain visibility, we talk about a growing industry, and now, we talk about an industry that has, significant volumes of product that's being moved around, 76 billion, right? So, as an organization, we kind of took a step back and we said, well, okay, now that we know, Intel's having this issue, now that we know that, the industry is very large, right? Let's go out and talk to, some of these customers, some of these logistics companies, and let's validate that, in fact, this whole idea of visibility, this whole pain point of visibility is, resonating within the industry, not only within Intel, and understand what kind of impact that's having on their business. So as you can see here, I think our team spent close to 2 years meeting with third-party logistics companies, meeting with end users, attending conferences. And this is probably some of the most impressive data data points that we found, right? So first one is 30% of the 76 billion shipments that I mentioned on the previous slide are either damaged, delayed, or lost every year. 30%. $60 billion of cargo is stolen per year. And these figures, by the way, are globally. 2.2 cargo thefts per day in the US with an average value of just under $250,000, right? Now, the next item is, it's a very interesting one because 30% of perishable goods don't reach fork from farm. It is really amazing when we talk to these food and vegetable manufacturing companies, the amount of product that gets thrown away as a result of issues that they have throughout the supply chain, that as a result, decrease the shelf life of the product, and retailers won't take the product, or they reach the retailer and all of a sudden they don't have enough time to sell it, so they have to mark it down, or they have to just simply throw it away. But aside from the amount of the cost that this brings, it's also a big social problem, right? In countries such as India and such as countries in Latin America, and I'm from Peru, for example, that I can clearly resonate with this. This figure is actually larger than 30%. We've heard anywhere closer to 50 and 60% in those instances, right? So it's almost like trying to tackle this issue of perishables. You're tackling this idea of trying to solve hunger for a particular region of the world, right? 76% of global companies reported disruptions within the last year, right? I can, again, resonate to this. Like I mentioned, I spent some time in the procurement organization, and I can tell you that not only are these disruptions very costly, we're tend to react by then shipping stuff around the quickest way possible, and that's not cheap. But also it's a resource drain, right? All hands on deck if you have a 24/7 operation, right? So taking away people's time from working on something strategic to working on something tactical, it could be something as simple as just moving, a cargo from point A to point B because there is a significant delay. And anyways, and then the figures down at the bottom are in monetary, right? So to us, Intel, we did a calculation that, a delay stopping fab manufacturing or production because of raw material availability could potentially impact, revenue by $1 million. Very significant. We talked to the world's second largest pharmaceutical company in Europe, and they're keeping roughly $100 million of emergency inventory just because they need to make sure that these supply chain disruptions, right, don't impact them fulfilling orders to the end users, right? And lastly, the world's largest apparel manufacturer says that they see roughly $500,000 per month in theft, in their apparel theft in Mexico alone, right? So they already account this for their top line and bottom line figures, right? So as well as when they're managing inventory and then when they're producing items, they have to take this into consideration. So naturally, we went out and when we talk about supply chain visibility, we went out to see what kind of solutions are out in the market today. Right? They call it a gap analysis. And if you're in the logistics and the shipping industry, transportation, you may recognize some of these that I mentioned here above: Sendem, OnAsset, Intelligence, Skybits, Omnitrack, Spirion. Right, and I can summarize the gaps seen across all these technologies into 5 main categories. The first one is a lack of a cost-effective way to track at the individual package level. Right, a lot of these products out in the market today, given their price points, are being used to monitor a specific percentage of the 76 billion shipments that I mentioned earlier, right? But not at the individual package level, at the container, right? So you're shipping pharmaceuticals and you're interested in monitoring the temperature throughout the journey. As they get loaded into the truck, you add one of these devices, and it monitors the product, at the container level. Now, one of the challenges here is that if you talk to let me go back to the perishables example. If you go back to a food manufacturer, one specific here in the US was talking about the sensitivity of berries to temperature and how they were interested in monitoring the temperature and humidity of the berries at the individual pallet level, right? Because there was such a deviation, they were so sensitive to changes in temperature that they needed to do that, right? And sometimes container level tracking was not good enough for them, but there wasn't a cost-effective solution to do it, right? So they would sometimes just put a couple of these, they would take the cost hit and put a couple of these in a container, right? Now, the second one is the lack of options to ease reverse logistics. A lot of these items, once you ship them from point A to point B, they don't make it back to point A, right? And the reason being is it's very difficult, right? So you either ship them independently, you either have to keep inventory of these devices at both sites, right? Unless it's a back and forth point A to point B transportation lane, right? It is very, very difficult to kind of move these around, right? And you'll have to establish a very robust business process to do so. So what these logistics companies tend to do is just, send it as a one-time use. So if one of these devices is in the $400 or $500 range, right, you're paying that amount of money for just a one-time use. especially if you're shipping internationally. It can get even more complicated in the burden of resources associated with getting these back to the country of origin. It's just not worth it, right? The third one is lack of edge intelligence and granularity of data. A lot of these technologies and products rely on control towers, on someone to monitor, real time the readings and manually send out alerts to either the driver or the carrier, right? That something is happening to the shipment, right? And again, the granularity of data is tied directly with number one, right? So, the ability to track at the individual package level, you'll get potentially an alert at the container level, but you don't know specifically which product is experiencing, a change in temperature threshold, for example. You'll have to do that analysis on the spot, and that could be very time consuming. The next one, limited end-to-end hardware-enabled security. Most of these solutions they have software that enables, some sort of security, and this is good, right? But we constantly talk to third-party logistics companies. We talk to end users, and they're extremely sensitive to the data, right? And making sure that this doesn't get out, right? Especially if you're shipping very sensitive material or information like for example, Intel's very, very sensitive about where they're getting, where we're sourcing, certain types of equipment, the volumes, etc. And we want to make sure that that information doesn't get out to the public or get out to our competitors. And the last one before I move on here is the lack of interoperability and standards. What does that mean, interoperability? And right, and I can give you two main examples, right? So the first one is the inability. These devices and products don't talk to each other, right? And even what we've seen is that as new generation of products from the same line in manufacturing come out, right? They require a major overhaul, specifically on the back end integration between the data that gets uploaded here. I apologize. And the data that gets collected and how it gets fed into the enterprise data systems, right? So if you want to switch from one product to the other, for example, you're running a product A, and then next year there is a product B that it's a significant improvement, right? You have to go through a major change management protocol to make sure that this new product gets integrated, and that's not very easy to do, right? Knowing again, relating to when I used to work in supply chain at Intel, that this can take a lot of resources, a lot of discussions, a lot of manpower. And the second example that I wanted to give you, right, is that if you have products where you're interested in you see that there's significant value on trying to monitor, multiple condition parameters, you're going to need multiple devices, right? And like I mentioned, these devices don't talk to each other, so it's going to be a significant amount of work again to do the integration, whether and there's no way of doing so at the edge. We'll have to do it in the backend data system, and just more opportunity for failure here. All right. So with all that in mind, right, we talked about trying to address Intel's supply chain major challenges around visibility. We talked about the logistics industry as a whole. We talked about some of the products are in the market today and their gaps, those products that are trying to address the supply chain visibility problem. So now let me shift gears a little bit as to what we have developed, right? What is the Intel Connected Logistics Platform, right? And this slide is pretty hardy, but I'll try to be as descriptive as possible here. And so you can think of this as a platform consisting of three major components. And let me start with the middle here, with the gateway. Right, so the gateway is a device that measures, temperature, humidity, shock tilt, all these parameters here on the right, and that gateway, it can be placed in the back of a trailer, in the back of a container. It can be placed on a pallet, you name it, and this uploads data to the cloud, right, via Wi-Fi or cellular connectivity. Right, so here I have cellular, but it should be cellular and Wi-Fi, right? Now, it can get measurements, at any desired frequency. Battery life will vary depending on that frequency. We've seen anywhere between 15 to 60 days. It's got a rechargeable battery. Now, here's the main differentiator versus and this is, I would say this is what's, the value that this platform has, right? Is that if a customer or if a third-party logistics company, right, an end user wants to monitor now at an individual package level, right, they can attach sensor tags, smart sensor tags, that have the same sensing capabilities as the gateway, and these sensor tags can actually communicate to each other, right? So you can imagine if you have a shipment, let me use an Intel example. If you have a shipment coming from a supplier OEM of capital equipment in Asia, and they're shipping 15 crates in one container, right? And they are trying to monitor shock and tilt for each one of these crates, right? You could put one sensor tag in each crate, right? And the sensor tag is about the size of a credit card. I have a picture in later slides that I can show you, right? And these can communicate through each other through a mesh network, and they will upload their readings, right? Again, you can fine tune the readings of the sensors at any desired frequency. They upload the data to the gateway, via 15.4 radio frequency, very low power. And then the gateway will upload that information to the cloud. So back to my example, right? Now you have the ability to get all this condition and location readings at the individual package level, right? By using a simple smart sensor tag that they all communicate to each other, right? So that you can do a lot of, predictive analytics. So for example, if someone is running away with one of the packages in the shipment, it can trigger an alert based on proximity, and send an immediate text message to the truck driver that say, hey, you should stop, something's happening, or call the police, or do something else, right? And you can picture this gateway, right, either traveling with the 15 crates, or this gateway can be instrumented on the truck or container itself, right? And that's, we've set ourselves off in a journey to help build out this infrastructure of gateways so that you can, as a shipper, right, you can effectively drive the cost down of individual package level monitoring, right? That supply chain, that visibility that we were talking about, down to the cost of just one smart sensor tag, right? And to further expand the use case, right, and to truly make this end to end, right? You can figure out, you can put together a scenario where you have these gateways. So say you're building out an infrastructure of gateways across, containers or trucks, and now you have gateways in the warehouses. We've developed a change of custody protocol for these tags so that they can go from reporting information from one gateway, for example, maybe it's sitting in a warehouse, right, to talking to a gateway that's potentially sitting in a truck, right, while in transit. And then it gets dropped off into a distribution center, and these sensor tags can then start communicating to the gateway at that distribution center, effectively, giving you real-time end-to-end visibility to the condition and location of your shipment. I see some questions, so we'll take a pause here. What about the location of the containers, pallets, or crates within the building or within the warehouse? Right. So one of the next, the first revision of this product, will be using the GPS that's located on the gateway for tracking, the shipment across distances. But we're also looking at Bluetooth technology that these smart sensor tags have, so that you can get some additional granularity of the location of these, we'll say, pallets, while they are in a closed warehouse environment. Next question: what technology does Intel have for indoor and outdoor location tracking? Right, I would say that effectively, this technology can do both, right? So we have essentially, fixed the whole issue of visibility during the transportation process, by having the mobile gateway travel with the shipment, right, real time. And indoor, like I mentioned previously, right? So we will have to, make use of instead of the radio, potentially Bluetooth, etc. And like I said, without going into much detail of our roadmap, since that's confidential information, just want to keep it at that we're working on the indoor for the next rev of the products. Let me see, where GPS is not really the right choice due to power requirements and costs. Not sure where GPS, not sure I understand the question. Are you saying that GPS is not the right choice, or is that a question? Maybe Raj, Nukala, if you can just clarify here. Now, in the meantime, I'll jump to, are you looking at LPWA technologies such as LoRa, WAN, or Sigfox? Interestingly enough, I did have a conversation with Sigfox about 3 weeks ago at the IoT Solutions World Congress in Barcelona. Very interesting technologies. I would say that the use cases are different, right? So my understanding and from what I learned was that Sigfox was, mainly targeting location of some of these containers. They weren't at the moment. They weren't working on technologies to do this kind of condition level monitoring, right? I do have to say they have a very interesting approach, right? Using their own cellular towers to do the location tracking, right? But again, what my short answer would be, we're trying to tackle two different use cases. So back to the GPS question, just that sometimes GPS could be costly as a binary integrated to the end product to get real-time location tracking. I think what I'll do is I'll take this back and just make sure that that this gets answered. And maybe put you in contact with a technical expert that that can talk a little bit more about GPS and the effectiveness and cost, etc. Yes, you can contact me, and we can have a discussion on LPWA, or at least, again, I can put you in contact with an expert, and with myself included, and discuss that in more detail. But what I want to do here is we have a couple more slides. I want to make sure that I get through all of it before we jump to more questions. Okay, so just to wrap up, right? So the Intel Connected Logistics Platform, you saw the architecture, right? So from an Intel IoT standpoint, right? So we have here an opportunity, to be a leader, take a leadership position in an industry really that has seen little to no investment in technology, right? So I think I would say, in comparison to the amount of money that gets spent in logistics, right? You saw $8 trillion, right? So, what are some of the I would say 3 items that we are doing here that are key, to the to the concept of scaling this and making sure that this is closely aligned with our overall Intel IoT roadmap. Is the first one is reusable building blocks. All right, so we've created a platform, that's going to allow our ecosystem partners to use a pre-integrated solution, right? And for faster time to market, and as a result, lower development costs. The second item is intelligence from edge to cloud. Right? Going back to one of the gaps that we saw across the industry is we're trying to bring this decision making, predictive analytics down to down to the edge as much as possible. And lastly is security, right? So again, you talk to these companies, logistics companies and users, and they want to make sure that their data is secure. So Intel, right, through silicon, and one of the important things is through silicon and software, right, where we're creating a security foundation, both in combination, so that we have a product portfolio, right, that has a security foundation that's above and beyond what the industry wants. So again, and I want to wrap this up so that we can get to the questions as well. So with that, right, I want to introduce you and you may have read some publications if you have learned about this connected logistics platform. So Honeywell has released the first OEM solution based on this architecture, right? They announced this back in May 18th, right? Right now, in conjunction with us, we're in pilot phases, and they will go into mass production of this product probably by the end of the year, right? So, recall that what I'm showing here on the left is the gateway, the front of the gateway, the back of the gateway, and like I said, it's about the size of an iPhone 6. It's NFC enabled, and it even has a microphone that will be used to detect engine noise while it's either taking off or landing, to help the device go into airplane mode. Right, so that's a very neat functionality that Honeywell has brought to the table here for this product. The smart sensor tags are, like I said, about the size of a credit card, about an inch thick, and they're also NFC enabled, right? So you don't necessarily need to have a gateway, a Honeywell gateway, to extract the data. You can simply, extract it through, we'll say, your iPhone, and upload the data to a user interface that Honeywell, or an app that Honeywell has developed as well. These tags are they're non-rechargeable, unlike the gateway, right? So I think the expected lifetime of these is just over 3 months, right? So if you're an end user, if you're a shipper, maybe this is a one-time use for an ocean shipment from the U.S. to Europe. But if you're making constant shipments inland, these tags can be reused for multiple shipments. All right, so essentially, once a shipment is made from point A to point B, the data is cleared at the tag level, right? And you can go off and use it again for maybe the next shipment going from point B to point C. How these will get attached to the shipment, like I said, these tags will either go on a crate, will either go on a pallet, on a box, depending on the granularity at which the shipper or the end user wants to track this condition monitoring. And you can see on the back here, this is a military grade Velcro, can be applied. It can also, there's an adhesive SKU, And if if you don't want to damage the exterior part of the container, Honeywell is also providing these almost these transparent bags that have minor adhesive to that can be attached to the pallet or to the box, right? And likely and similar, like with the gateway, we can do either one of those options, right? I mentioned that we're going into pilot. We're piloting this product. We're working right now we're actively piloting this product with 3 major third-party logistics companies. We're engaged with 20 more that are very interested, and we're working to identify which lanes work best. Right. Honeywell recently received airline certification from one major carrier, and on the verge of getting 2 more. I always say that the first airline certification is the toughest. We successfully executed the first ocean shipment from, I believe it was from the U.S. to China. So 60 days, or yes, 60 days total, with some dwell time along the way as well. So, progress is being made. Constant, updates are being made as well. But like I said, this is available in the market today, and we are working very closely with Honeywell, with our shippers, logistics companies, to make sure that that the solution is doing what it's intended to do, and it's addressing their major pain points. And lastly, to wrap up the presentation here, right? What we've segmented, our target markets into 4 main ones, right? So if you ask yourself, okay, well, this is great. You can do all this condition monitoring down at the individual package level. You're working with shippers, but who's actually, interested in this, right? Who's actually wanting to pay for who's actually going to see ROI as a result of this visibility? And I would say 4 major markets, right? And you can tie this back to one of the original slides that I shared with you on the supply chain data, right? The first one is capital equipment. Working with large manufacturers who are interested in monitoring the condition of their equipment. This is sometimes multi-million-dollar equipment. You can think of like airline companies, you can think of power transmission companies, even Intel's own capital equipment supplier OEMs, where historically, this has been done with analog devices, right? Standard shock watches, tip and tells, and really it only tells me whether the shipment has undergone a certain shock event, or has the item been tilted, but you really don't know who has done that. Right? The next segment, I would say high value goods, and this is primarily electronics. To give you an example for Intel, we're constantly shipping processors from our major distribution centers in the southern part of the United States. So there is significant interest of monitoring at the individual box level, right? Because they are extremely, how would I say, prone to theft, right? And similarly, we're working with other electronics companies who want that same level of visibility. They want that same level of real-time alerts on their products. I mentioned previously in the presentation, pharmaceuticals. This is a big segment too, and this is primarily over air freight. I think it's over 70% of the shipments are pharmaceutical shipments worldwide are made via air, right? So again, the main driver and main value proposition for them is temperature and humidity control, right? So you'll be surprised that even some of the largest pharmaceutical companies the technologies that they're using are mostly analog based, and you know that as a result, they have to keep those large amounts of inventory. They have to overproduce and sometimes throw away some medications that, you know, could potentially save lives if they weren't damaged, or if they didn't endure outside of the standard thresholds during the in-transit phase. And lastly is perishable items, fruit, vegetables. You know, I gave you the example of berries earlier, right? Looking at everything from, you know, raw materials for some of these, you know, we'll say drink companies, you know, major sports drink companies, right? That they're interested in tracking the temperature and humidity of the syrup, to, you know, to end product like, you know, we'll say berries or bananas being shipped from the manufacturing sites and to all the way to the retailer. All right. So with that, you know, that concludes the presentation. Hopefully, you know, I gave you an overview, and I'll jump into the forum here to see if there's more questions, right? Give you an overview of Intel supply chain, you know, the motivation, and, you know, we are trying to, specific to logistics and asset management, you know, we're trying to solve our own supply chain problems first, right? But we know that the rest of the industry sometimes shares these pain points as well, right? So again, closely partnering myself and the supply chain teams to make sure that the products that we develop are, you know, are well suited for the target industry. It is very, very critical. Right, and with this Intel Connected Logistics platform being one of the first ones in our portfolio, right, having really the opportunity to develop a platform from the ground up that you know gives the shippers and end users a very, you know, flexible solution to do, you know, really, you know, what they want with it in terms of condition and location tracking. Right, and you know, to the questions that I answered earlier, you know, this is the first, you know, the capabilities that I mentioned earlier, you know, are mainly for in transit and short stops while in a distribution center, in a warehouse. You know, we're definitely interested in tackling, you know, this indoor asset tracking problem as well. Right now, the challenge there becomes of whether, you know, a tag like the one we have designed through Honeywell is of the right cost, right? Because now at that point you're competing with RFID, right? Which it's in the cents, and we're most certainly not going to be able to get our tags down to that price point, right? So again, you know, if you have any questions, I have my email up front in the front slide. Take a step back and answer questions that you guys may have. Do these Honeywell sensors have any sort of tamper identification? Tamper identification, what do you mean? If you're trying to troubleshoot the Honeywell gateway or the tags yourself? I would say if that's the case, you know, I think we can work together with, that is, if one tag is removed from one crate or container and placed on a different one. So yeah, so what I would say is that the tag is, there is the process to provision a tag with tag and gateway with the shipment, right? You will associate a crate with that tag, right? Now, if someone takes a tag from a particular crate and then moves it to a different one, all right, I think you can work through the mesh network to say, hey, maybe there's a proximity alert between now the tag on the crate that already had the sensor tag and now the new tag that you just placed on it, right? But again, that'll have to be worked by depending on the use case, and we would have to look at how far apart are these crates being placed generally. But off the shelf, if you were to move one of these tags, they wouldn't. You wouldn't get an alert that says, "Hey, someone removed it from the package." That's a good point. Unless someone is running away with the tag, or maybe the tag fell off at one of the truck stops, right? It can definitely sense that, and it can send you an alert so that the truck driver can stop and see what's going on. How about cell connections? How this could lower costs? So I think to answer that question, maybe I can tell you a little bit more about the business model for the Honeywell product specifically, right? So what they would do is, I mentioned previously that that we have essentially lower the cost of condition location monitoring just to the cost of the tag, right? So what they will do is they will lease you a gateway, right? Maybe you're a shipper and you have a fleet of 100 trucks. They will lease you 100 gateways, right? And you would pay a monthly fee for that gateway. We'll say about $20 per gateway per month. And you will just simply buy tags from them, right? And they will take care of the cellular backhaul costs. They will take care of the troubleshooting any issues that you may have. They will be providing level 1 support on the hardware. And additionally, they'll provide you, Honeywell will provide you with their mobile application, with their desktop application, a user interface that you can go and essentially track your shipment, track the condition and location of each one of the tags, of each one of the gateways. You can see a map that I wish I had included a picture, but you can see a map and where your shipment is or are, right? Because you can have multiple shipments, and if your company will say 100 trucks and maybe they're all moving at the same time, right? You can monitor all of them from one stop. And that same application will have the provisioning steps that I mentioned, as my answer in the previous question. So what's the battery life of the tags, and at what frequency do these wake up to transmit the data to the gateway? So the battery life of the tags, it's like I said, we've tested them and we're seeing about 3 months. So 3 months for the tags. They're not non-rechargeable for now, at least for the first revision of the product. And the gateway is 15 days to 60 days with a rechargeable battery, depending on the upload frequency to the cloud. Now, the second part of your question, what frequency do these wake up to transmit the data to the gateway? This can be done, I think we've done tests at a minute, at 5 minutes. So really, the frequency it can be determined by the end user. What types of personas are you targeting with this platform? Hopefully I answered them on the last slide, right? So we're looking at 4 different ones, folks that are shipping, high value capital equipment, high value goods, perishables, pharmaceuticals, and we're actively working with shippers and end users from each one of these segments. Yeah, so contact me via email. I think email would be best. You can also look me up on LinkedIn. I would be available then. So following up on the question on the frequency, the exchange of messages between the gateway and nodes, is it co-op based? The communication protocol between the gateway and the sensor tags is via 15.4 radio. The reason why we went with that as our primary, means of communication is to preserve battery life, right? And like I mentioned earlier, we're looking at also integrating with Bluetooth so that you can get a better granularity of the location of your assets in an indoor environment. What is the total number of tags that the solution was tested. So theoretically, and again, we'll have to ask how our technical folks came up with this number. So theoretically, you can have almost 1,000 tags to a gateway. Now, realistically, that scenario may not happen very often, if at all, right? So if you're looking at a shipment, at the most, you'll probably have 40, 50, and that's the range of the testing that's the upper threshold of the range of number of tags that we're doing in our pilots. The majority of the use cases that we're tackling is probably in the 10 to 20. Actually, I would say on the 5 to 20 tags per gateway per shipment. So again, theoretical is one piece, and what's actually being done in the field is another. So making sure that those use cases are robust is our focus. Okay, so let's say we want to only capture, excuse me, certain parameters, like for example, temperature, right? Do we have to pre-program the tags before install, or can we do it over the air? So let me answer this question two ways, right? The first one is you can provision your tags, right? To do, so there's one SKU of tags right now, and they have all those condition monitoring specifications, right? So if you're only interested on temperature, you can specify the thresholds during the provisioning phase, and as when you're working with Honeywell, as a shipper, this may be more of a commercial discussion, because right now I don't think that they will be manufacturing different SKUs of tags for just individual parameters, right? So I think you'll get the same tag. It's just you'll just be monitoring temperature. You can set the thresholds in advance. It may be to your benefit. You may get commercial breaks if you're only using less data, right? That would be the answer to my question. What is the competitive differentiation of this platform from others, if any? What I would say is that competitive differentiation, so a couple things, right? The first one is, through this platform, we're able to deliver the individual package condition and location monitoring in a cost-effective way, right? So I'm trying to address the gaps that I shared previously, right? So the cost of these down to in driving the cost down to just the price of these tags, which could be anywhere between $10 and $20 per tag, right? No other solution in the market today will give you condition and location monitoring for that low, right? So one is cost. Reverse logistics, right? So reverse logistics, given that the low cost of these tags, right? When we complete building out the infrastructure, right, of the gateways, right? Essentially, these tags can just be a one-time use. Given the low cost, $10, $15 per tag, I may just want to throw them away after I use them, so I don't have to worry about establishing a reverse logistics loop, business process, etc. Right? Interoperability. I do want to make sure that I highlight interoperability. Right? Through this platform, you get all these condition and location monitoring parameters: shock, tilt, vibration, temperature, humidity, light, proximity. Right? In one platform, right? And this platform can be used, even with the Honeywell solution, right? So you can use their user interface, which is basically an off-the-shelf product for you to get access to condition monitor, real-time condition monitoring of your shipments. Or they have some APIs that they can publish, so you can integrate into your data systems, right? Through some APIs. I would say those are the three major ones. It's a cost at the individual package level, ease of reverse logistics, interoperability. Right? What radio technology are you using? So keep in mind the radio technology is between the sensor tags and the gateway. And this is Zigbee 15.4. How reliable is the Zigbee communication in the containers? Again, I would say it really depends on the use case and the type of containers, right? So we have a couple heuristics that we've developed. So, for example, the gateway will need to be in the trailer because the Zigbee the radio doesn't go through the thick layer of metal that the containers are made out of. I think that's one of them. And then the other thing, so then it's about, I would say, we've seen 200 to 250 feet between the gateway and the tags. So meaning that you can take a tag out to 200, 250 feet away from the gateway and it still communicates to it, right? Did you see the 100% reliability? So like I said, we have not tested 100 nodes. We have tested, I believe, up to like 30 or 40, and we have seen 100% reliability. So meaning that the gateway does recognize and identify all 100 nodes. Thank you very much. Again, if you want to follow up, I think email's best, LinkedIn probably second best. So have a good rest of your day, evening, and thank you again for your participation. Bye.